pretty close on the dot. Okay, so here are my observed. My observed are 62 accidentals, 23 homicides.
Like, you don't know how helpful you are.
5 suicides. Remember, I have to have a minimum of 5 in each category for my expected. Which these are my observed. So I'm okay. But if I add those up, I'm going to get 90.
Oh my god.
So here, this is, you saw, this is 90 times 74%. Right? What do you guys get for this one?
66.6.
And this one?
14.4.
And this one?
9.
Okay, good. So then we're going to take a look at our H0, H1.
Every single
H0 is O sub I equals E sub I. H1 is O sub I not equal to E sub I. You guys know the camera's on, they can hear everything you say, right?
Oh,
Then critical value is,
my bad.
let's see, so your degrees of freedom is equal to 2, because it's 3 minus 1. Alpha is 0.10. Critical value is what?
4.60.
So you're going to go again, steep up and then drift off. 4.605. Step 3 is your test stat. So this is going to be chi-squared. It's equal to, this one's nice and simple, right? 62 minus 66.6, this is just like your exam, over 66.6, plus 23 minus 14.4 squared over 14.4, plus 5 minus 9 squared over 9. And you will get, what do you guys get for that?
7.23.
7.23. So 7.23 further, don't forget, this is 0 over here. If you're not sure, look at your chi-squared table, and there's a little picture, and it has 0 right there in that corner. So this is going to be 7.23. So it's going to be a total reject, yes?
Mm-hmm. Yeah.
So there's enough evidence to reject claim. Your claim is that they're the same, right? Reject claim that percentages are as expected. And I think as expected is just, that's the simplest way. Certain percentages are as expected. Okay, the last one, skip the last one, we're going to do that one as our quiz next time. Yeah.
If we find test that using a calculator, do we just write down the L1 that's L2 equation?
I still need, you have to give me this. If you don't give me this, I don't care how you calculate that. You can totally calculate that with your calculator, but you have to give me those numbers so you prove me you understand where this formula comes from. I need that. Like I said, there's only going to be 3 of them. It's not that much to write down. You can handle it. All right, everybody's all good? Okay.
You always see that.
Okay. Now, we're going to talk about 11.2. Zach, go ahead and read.
A test of independence test. The null hypothesis that in a contingency table, the row and column variable are independent.
Homogeneity.
Homogeneity of proportions test is used when samples are selected from several different populations to see whether the proportions of each characteristics are the same between populations. Again, to be clear, we are not talking about cause and effect, merely association, just like correlation.
Right, we're not saying one thing causes the other one. We're saying that are they correlated or not? Are they independent? So, a contingency table are those tables like the puppies, right? Male, female, black labs, chocolate labs, yellow labs. You guys remember those?
Yeah.
And these two tests are the same, because if they're independent, you guys remember if they're independent, that means their proportions, their ratios are the same. You guys remember us doing that? We compared this ratio to the total ratio. That means that the proportions are homogeneous, the same. So these two tests are exactly the same. Here is the definition. Jenny, go ahead and read.
A contingency table or two-way frequency table is a table in which frequencies correspond to two variables. One variable is used to categorize rows and a second variable is used to categorize columns. The contingency table has at least two rows that has at least two columns.
Right, so for ours we had male, female. For our rows in our columns were like black labs, chocolate labs, yellow labs, right? So we had at least three columns, at least two, at least two. Here's another example, right? So here our rows are types of surgery or types of treatment, and then whether things worked or didn't work, success or failure. So another example of one. Here's our puppy one. And remember, before we were comparing to see if chocolate and male are independent. We look at the ratio 5 to 8 and see if it's the same as the ratio of 25 to 40. Everybody remember that sort of?
Mm-hmm.
You notice if the proportions are equal, then they're independent. Here we're going to be looking at all of them. So here we're looking at every single 48, every single one. So is this ratio the same as this ratio, the same as that ratio, the same as that ratio? In this case, they are. 5/8 is the same as 15/24. It's the same as 10/16. It's the same as 30/48. Those are the same proportions. So they're homogeneous. They're all the same. Now you've got to remember, this is a sample. So it's never going to be exactly perfect. There's going to be a little bit of range due to sampling that's acceptable, right? In other words, if I flipped a coin 20 times and said, oh my gosh, I got 20 times I got 12 heads, that doesn't mean that the proportion of heads is not 50-50. That's just due to some randomness. Everybody on board?
Yep.
Okay. So, the question is it reasonably, the same, or is it totally crazy different? And that's what we're going to be looking at. Same thing, kind of like we did a second ago, right? They weren't exactly the same. They're off a little bit. Notation, your O's and E's are the same. R represents the number of rows in your contingency table. C represents the number of columns. Not including the labels. H naught is, so for independence, H naught you can just use O sub I equals E sub I. You could also use P1 equals P2 equals P3 as many proportions as you have. The first proportion equals the second equals the third. For H1, you can just use O sub I is not equal to E sub I, or you can say at least one differs, either one. All right? Good with that so far? And I think that's just the exact same thing. All right, so couple of things. We have to compute what the expected frequencies are. I'm not going to make you compute all of them. I'm going to make you compute by hand the first one and the last one. Just two of them. And then you'll see what that means in a few minutes. The degrees of freedom are going to be your number of rows minus 1 multiplied by your number of columns minus 1. Okay, so far with that? We'll see what we mean when we get there, I suppose. And actually, you don't even have to worry about that in a sense because the calculator will take care of that for you as well. But here's the thing. So the test stat is exactly the same as the previous ones. Every observed value minus its expected value squared divided by the expected value. Degrees of freedom is R minus 1 times C minus 1. And then here's the other thing that's interesting, is your expected frequencies is every row sum multiplied by its column sum divided by the grand total. And we'll see what that means in just a few slides. Here's the beauty of it. These last two, 11.2 and 11.3, pretty much the calculator is going to do almost everything. Here, you're going to use stat test chi-squared test. You're going to have your observed values. You're going to put those into matrix A. So you're going to do chi-squared test of matrix A, and then here you're going to put your matrix B as your expected. You do not have to input the expected value into matrix B. The program, once you give it A, will compute B for you, and it'll save it and put it into B. That's what it's saying. So in other words, you're going to give it A and put numbers in there, and it's going to calculate the expected, and it's going to save them into B. Make sense? Yes.
Do we need to put the totals into A or not?
Nope. It'll do that for you.
Didn't think so, but
Yes.
just
Yeah, good question. Yep. And that will also give you the chi-squared value and the p-values. However, you do have to calculate the first and last expected values. So here there would be, this is a what by what? How many rows?
3.
How many rows, guys?
4, 5,
Of actual data, of actual categories.
4, yeah.
How many hospitals can you be at?
3.
3. A, B, or C. Everybody on board?
Yep.
What could possibly happen to you if you were in that hospital?
One of three things.
One of 3 infections. Everybody on board?
Well, listen, what's up with these grim freaking
Yes.
things?
All right, so this is a 3 by 3. Everybody good?
Yeah.
All right, so to compute this expected value, you're going to grab the row total. That means this is the total of that row. You can multiply it by the column total for that. This is its column total. And you can divide by its grand total. So here, this is going to be 119 times 246 divided by 582. We're going to call that the expected value for row 1, comma, column 1. I see people writing things down because they're good students. You're also going to find the last one. This guy here. So that's going to be the expected value of, which row is it? Third row and third column. So it's going to be 384 times 200. That's my column total. Divided by the grand total, 582. Okay, everybody all right with that? Those are the 2 things you're going to have to find. Everything else in this is the same as last time, very straightforward. Step 1 is the same, step 2 is the same, only your degrees of freedom are slightly different. Step 3, you're just going to do stat, calc, chi-squared, and I'll show you next class how to input a matrix. And then steps 4 and 5 are the same. All right, so we'll go ahead and talk more about this on Tuesday.
So is the lab like okay on Thursday? So like, is the lab like okay on Thursday?
Yes.